In this video, we'll go over what the word precipitate means as applied to chemical solutions. We'll also go over how you can identify whether a substance, like a salt, exists as an aqueous substance or a solid substance in a solution. So here are two examples of precipitation occurring in double replacement reactions. Do you have an idea of what precipitation means? Defined, a precipitate is a solid substance that forms in a solution from a chemical reaction. Precipitation is just the act of this happening. Precipitate can also be used as a verb. The solids are precipitating from this chemical reaction. Take a look at the stuff that's in the little parentheses of the chemical equation. Can you tell which product is the precipitate? The one with the S for solid. Just a reminder, the AQ means aqueous. So the aqueous product that is in the test tube here is dissolved in the liquid water. You should have seen the video by the NAGSAG lady. She made an ingenious mnemonic to easily remember what salts or ionic compounds are soluble and which ones are insoluble, meaning they would form a precipitate. This way you can remember if a substance is soluble or not, even if you're not given a solubility table. On the other hand, if you can look up the solubility table on Google. This one is one that I found on Wikipedia. And for this, just a quick mention, the S represents soluble, the I represents insoluble, and the SS represents slightly soluble. For this example, we'll identify what state of matter each product is in the chemical equation.
Now, I'll just let you know now that we're either going to be labeling it as aqueous, meaning it's dissolved, or solid, meaning it's a precipitate. The L is usually what we're going to put for water, because that's a liquid, and the G is what we're usually going to put for things like carbon dioxide or any of the diatomic molecules like hydrogen gas or oxygen gas or nitrogen gas. Okay, so just know that we're only going to be putting S for solid or AQ for aqueous in these examples. Our first product is silver phosphate. If we were to use the NAGSAG rule, you're going to notice that phosphate isn't even found on the always soluble column. If it's not found in the always soluble column, it already automatically makes silver phosphate insoluble, meaning it's going to form a solid precipitate. And that means we're going to just write in small parentheses S next to silver phosphate. Our second product is potassium nitrate. And if we're to use the NAGSAG rule, you'll notice that nitrate is always soluble with no exceptions. So that means we're going to be writing AQ for aqueous because it is soluble. AQ. If you were to use the solubility table on the top right, you would just actually match where you find the ionic compound. So for our first product, which is silver phosphate, silver and phosphate, it would be located right here, and you're going to notice that it says I for insoluble, meaning you're going to have a solid, which is what we said with the NAGSAG rule. And if we looked at our second product, potassium nitrate, potassium and nitrate, you're going to notice that it says S for soluble, meaning it's going to be aqueous, which is what we said with the NAGSAG rule. Okay, so you can use either form, whichever you like. I just want to let you know that the NAGSAG rule is really only there as a mnemonic for whenever you're not given a solubility table and you don't have any internet access for some reason. Here's the second example. Our two products are written right there. The first product is copper 2 chloride. If you were to use the NAGSAG rule, you'll notice that chloride is part of the group 17, the halide ions. And there are exceptions for group 17. You see that pink asterisk? The exception is the PMS. If the chloride is with lead or mercury or silver, then it is not soluble. But since we have copper with chloride, It's not part of the exception, meaning it is going to be soluble, and we are going to write AQ for aqueous. And our second product is going to be aluminum bromide. Bromide is also part of group 17, which has the exceptions, but aluminum is not part of the three exceptions. So aluminum bromide is also going to be aqueous because it is soluble. If you're going to use the solubility table to figure this out, you just simply find them on the solubility table. Copper chloride, our first product, it's going to say S for soluble, so it's supposed to be aqueous. And our second product is going to be aluminum bromide, and you're going to find it is here, S, so it's soluble as well. Aluminum bromide is aqueous. Here's our last example. We have two more products. The first product is aluminum hydroxide. Now, if you try to find hydroxide, you won't find it on the always soluble part. So it's most likely that this aluminum hydroxide is going to be insoluble, meaning it's going to fall out as a solid precipitate in this reaction, in this solution. The second product is going to be ammonium nitrate. Now you're going to notice that nitrate is part of the always soluble column with no exceptions. So this automatically makes it soluble, and ammonium nitrate is going to be aqueous. If you were to look at the solubility table instead, aluminum hydroxide, our first product, is going to be found right here, and it says I for insoluble, so that means it's supposed to be solid, which we wrote already. Our second product was ammonium nitrate, and if you find ammonium nitrate, you're going to notice that it says S for soluble, so it's supposed to be aqueous, which we already wrote. Here I have two chemical equations where the products aren't listed, whether they're solid or aqueous. I would like you to state what state of matter these products are going to be manifesting in after this chemical reaction. So you can use either the nag-sag rule or you can use the solubility table. Go ahead, pause this video. In about 5 seconds, I'll show you what the answers are. And there they are. So for each of these, they both actually form at least one solid. So you would be able to predict, without even doing this reaction, that there's going to be a solid precipitate forming from these reactants combining together. I have just one practice for you to try. Why don't you go ahead and try it, and I'll give you feedback for it.